We are continuing in our workbook in Precalculus section 3.5, which is about trigonometric identities. And in our last video, the first part, we looked at the identities in our packet for ratio, reciprocal, Pythagorean, even, odd, cofunction, and periodic. And we want to use them now to solve some problems in the notes and also obviously in the homework. So we will do this first example using trigonometric identities, but starting in the next sections of Unit 3, we will actually graph these angles and do it graphically. So we will not use identities. Identities are a little more engaged and lengthy than it would be if we were to graph. But the other examples that we will look at in this video are examples that you will see, you can potentially see in tests, but also you will see in homeworks, and there are not explicit mini video lectures in the Lumen courseware. So we have an example here. Our first example is an angle theta in quadrant 4. So it is, the terminal side will be in quadrant 4, and it's such that the cosine of theta is 3/4. So if we pick a point on the terminal side, and we draw the triangle attached to the x-axis, the x-coordinate will be +3. The r, the distance of that point from the origin, will be 4. And then we want to find the y. And this is how we would do it graphically, but what we will do, just for the sake of this example, because we are trying to solve this using trigonometric identities, is to remember that y will be negative, and therefore that will make the sine of theta negative, and also the tangent of theta negative. And then in some future videos, we will use x, y, and r to solve problems. But for now, we will just remember that the y is negative in quadrant 4, and therefore the sine and the tangent will be negative. We do have a trigonometric identity, cosine squared theta plus sine squared theta is equal to 1. If we know the cosine, we can find the sine. So the sine squared of theta will be 1 minus the cosine squared of theta. And from here, the sine theta will be plus or minus the square root of 1 minus cosine squared of theta. Now, in quadrant 4, we will choose the negative solution because the sine is negative. So I can find the sine of theta. It will be minus the square root of 1 minus the cosine squared is 3/4 squared, which is 9/16. So that will be negative square root of 16/16 minus 9/16, which is negative square root of 7/16, and the square root of 16 is 4. So negative square root of 7 divided by 4. The tangent of theta from the ratio identity is sine of theta over cosine of theta. The sine is negative square root of 7 divided by 4. The cosine is +3 divided by 4. The 4's will cancel out. The tangent will be negative square root of 7 divided by 3. Again, we want to solve in a different way. We have an acute angle theta. That means that theta is in quadrant 1. That means that they are all positive. The cosine, the sine, and the tangent. And they are giving us the cosine of theta. So use the cosine of theta in all of your expressions. And again, we will be doing the same things that we did previously, only previously we had a value for the cosine of theta. Now we just have a quantity, let's say A. So again, sine squared of theta will equal 1 minus the cosine squared of theta. The sine of theta will equal plus or minus the square root of 1 minus cosine squared of theta. And in quadrant 1, I'm going to pick the positive because the sine of theta in quadrant 1 will be positive. Therefore, the sine of theta will equal to positive square root 1 minus a squared, which is the cosine of theta squared. The tangent of theta is the sine of theta over cosine of theta. So the sine of theta, we found it to be the square root of 1 minus a squared. And the cosine of theta, they told us, is equal to a. So the tangent of theta will be square root 1 minus a squared divided by a. The cosine of negative theta, I'm going to use the even and odd identities. For any angle x, the cosine of negative x equals the cosine of x. So the cosine of negative theta will be the cosine of theta, and the cosine of theta is equal to a. A similar example, this time we have to find an expression. They are giving us the sine of theta equal to a and the cosine of theta equal to b. And they want us to write an expression in terms of a and b, which means in terms of sine and cosine, for the tangent of theta plus the sine of negative theta plus the secant of theta. So basically they want us to write these, the tangent, the sine of negative theta, and the secant of theta in terms of sine and cosine of theta. So the first one will be the ratio identity. The tangent is sine over cosine. So the tangent will be sine of theta over cosine of theta. The next is an even odd identity. The sine of negative theta will be equal to minus the sine of theta. So that will be minus sine of theta. And then the secant of theta, I will use a reciprocal identity. The secant of theta is 1 over the cosine of theta. I have expressed everything in terms of sine and cosine, and I will now replace them with a and b. So I have a divided by b, that's sine over cosine, plus minus sine will be negative sine, the sine is a, and 1 over cosine will be 1 over b. If they ask me to add fractions that have common denominator, I could potentially add the 1 over b and the 1 over b. A over b plus 1 over b. But that depends on what the question is asking. Here is another one. Again, they are giving us an angle theta. They are giving us the sine and the cosine. And they are asking us to use identities to write in terms of a and b the cosine of 4 pi plus theta. So for that, I will use the periodic functions. So the cosine of theta plus 2k pi equals the cosine of theta. So cosine of theta plus 4 pi will be cosine of theta plus 2 times 2 pi. So this is a k equal to 2. And per the periodic functions, this is equal to the cosine of theta because the angle 4 pi plus theta is in the same location with theta, is coterminal. So this is cosine of theta, and cosine of theta is equal to b. The angle theta minus 10 pi is theta plus 2 times negative 5 pi. And here we have a k equal to negative 5. And again, from the periodic functions, the sine of theta plus 2 times negative 5 pi will have to equal the sine of theta. So that is also equal to the sine of theta. And the sine of theta is equal to a. The last one is the sine of pi halves minus theta. So we are actually in this group of equations. These are called cofunctions. We are talking about the complementary angle and the sine of 90 degrees minus theta, which is the same with pi halves minus theta. The sine of that angle equals to the cosine of theta. So this is equal to the cosine of theta, and the cosine of theta is equal to b. One last group of trigonometry problems that we use trigonometric equations to solve is to verify given identities. This is actually an important topic, but for this chapter, we are just going to do a preview because we will focus a lot on Unit 4 in pre-calculus on how to verify identities. So for the time being, this is just for us to get exposure to how we use identities. We use the formulas in our packet to verify identities. One key thing about verifying identities is that there are two ways to do so. One is to, alter both sides of the identity and make sure that they are equal to each other. And the other one that we want to practice in pre-calculus, because it's a skill that we will need in calculus, is to start from the one side and go to the other side. So the very important part here is that when you are verifying identities, we want to start from one side and derive the other. Do not alter both sides. So that's very important as a skill that we need to learn. So I'm going to start from what I think is the most complicated side, which is here the cosine theta times tangent theta, and I'm going to use identities. I'm going to use the ratio identity, tangent theta equals sine theta over cosine theta. So here I'm multiplying two fractions. One is the cosine of theta times 1 over 1, and the other is the sine of theta over the cosine of theta. When I multiply fractions, I multiply the numerator and the denominator, and the numerator and the denominator are factored, so I can simplify the cosine of theta, which is a common factor. I will end up with sine theta over 1, which is equal to the sine of theta. And this is how I verify the identity. I do math on the complicated side, and the algebra will result in the simpler side. So I'm going to try the next one. I think the most complicated side is this one. So in the numerator, I have cosine squared of theta. And when I look in my formulas, there is one formula that has the cosine squared. So I'm going to solve the Pythagorean identity for cosine squared. Cosine squared will equal to 1 minus sine squared. So the numerator here will be 1 minus sine squared of theta. The bottom is 1 plus sine of theta. The numerator is a difference of squares, so it is a squared minus b squared. This is a 1 squared. B squared is the sine of theta squared. So I'm gonna factor it out as a minus b, a plus b. So I'm gonna write it as a minus b, so 1 minus sine theta, times a plus b, 1 plus sine theta. And the denominator is 1 plus sine theta. And now I have factored this fraction and I can simplify common factors. The common factor is 1 plus sine of theta, and the remaining is 1 minus sine of theta divided by 1. And therefore that's 1 minus sine of theta. And again, I did algebra on the one side and I derived the other side. For the next one, I could think that the left is more complicated or that the right is more complicated. So just to switch things, I will start from the right and I'm gonna try to derive the left. So I'm gonna start with secant theta minus cosine of theta. And I'm going to use the reciprocal identity to write the secant as 1 over cosine of theta minus cosine of theta over 1. I need common denominator to subtract these two fractions. So I'm going to multiply the right fraction with cosine theta over cosine theta. I will get 1 minus cosine squared of theta over the common denominator, which is cosine of theta. And 1 minus the cosine of theta from the Pythagorean identity, 1 minus the cosine squared of theta from the Pythagorean identity will equal to sine squared of theta. So this numerator is the sine squared of theta, and the denominator is the cosine of theta. And I derived the left side from the right side.